How's it going, everyone? It's kind of weird just going straight to live. I'm used to the like introduction scene, which on the YouTube recordings I cut out. Um, oh, ooh, you need to be quiet. Yes, thank you, YouTube. I know I went live. So, day number 2 of the switch to YouTube. We yesterday were working on getting our alerts, our alerts in our chat from YouTube into our scene. And our scene right now is done with React 3 Fiber, which uses 3JS, which is WebGL. Turtles all the way down. Which brings some very interesting things we can do with it, but also has some complications as well. And that's what we were dealing with yesterday. We were trying to get the chat to show up on the side. Which I should probably put it on this. Can we put it on this profile here? Let's see if we could do that real quick. We want it to be, I think I've only got it, I've got a test. Yeah, I've got a test text overlay. It's fine. We'll flip over in a minute. So we're trying to get the chat over here. And we are using a library called Dry, or we're currently presently using a library called Dry. From the same group that put out React 3 Fiber. And what it's doing is it's helping you through React 3 Fiber use HTML elements and match them up with WebGL elements in your scene. And we have a little bit of a unique use case where we want the WebGL elements to fit the content that is in HTML. And that's much more straightforward with CSS and HTML only. But it gets a little spicy once we start trying to adjust the WebGL elements to match that. So that's what we were working with yesterday. And at the end of it, we wanted to see how all of this would end up working with our physics system as well, because we can get it on there and it attaches, and we sort of like worked our way into the positioning that seems to work, but getting that text to be appropriately fit to the WebGL box is proving difficult. So before we dive too deep into trying to like derive that or do some DOM reference nodes or something of that sort, we are going to throw this into a physics system today and see how it works. And the way the WebGL and physics system are working is every frame, it's like a re-rendering or like updating the position. So we might be able to, as part of our physics system and setup, pull in the chat, get the reference to the height of that container, and then on the next frame, redraw or expand the size of our WebGL container. So that's my current thinking. And that might be fine because we have a pretty set width, I think. It's just gonna be that height. And we can kind of drop these in and like shift everything. So like redrawing it and that one frame difference, probably not gonna be that big of a deal. So we'll throw it into physics system and see how it's reacting and see if it works, and then we'll kind of go from there. So flip on over. I've got my code window up already. We need to start. I have not started it yet. And our test overlay is, we've got it, the chat test overlay in here. So once that starts up, I'll, on my stream deck down here, I've got a toggle. I can toggle it on and off so we can see it right away. We'll also open up it in the browser here so we can see it, and it'll be a little bit easier to debug, at least debug in a way that y'all can see. So the first time the scene loads, we get all of the GLTF items that we put into our scene. So in previous streams, we did some Blender. We created Blender 3D models, exported them as GLTF, and imported them to our scene. So that's probably going to be a thing that we hook up a command to, because when we were streaming on Twitch, we had a channel point redemption that triggered those. But we don't have those on YouTube. So we'll probably just switch that to a command. And maybe a command with some sort of permissions or something where you can drop a bunch of stuff. I think it'll be fun. But we haven't done that yet. That's sort of a to-do item still. Ideally, you want to get the chat done. Can we make the text a little bit bigger? Yeah, sure. I haven't really gotten into much yet, but we can do that. This is the file that we're going to be working in. How's that looking? Also, thanks for stopping by. So we'll restart the overlay, the chat overlay. So these are all our default values. Positionally, they seem fine. We'll have to work on the perspective and the depth, because since these are in WebGL, they actually have a depth to them, which we have set somewhere here. No, that's location. Box.z. Great. We could actually move this over a little bit too. We don't need quite so much of that terminal. For the most part, the terminal is just going to be sitting there doing the hot module reloading. So I'll keep a little bit of it visible, because every time we save, it's going to update. And what I'm kind of paying attention to is this time here. So I just want to make sure that timestamp changes. So that's really all I need to see. So let's just go to the chat. We've got in our React routes, we've got, I guess at this time, 4 routes. We got the root. And then for each of our 3 components, models, the text alerts, and chat, we have a route as well, just so we can isolate and debug each one of these things separately. And then the root has all 3 of them on top of each other, which they're in different WebGL scenes. So we might want to actually combine that at some point. Speaking of alerts, feel free to, where's the text? Chat's down here. Feel free to type the command !3D, the letter D, and the number 3, and any text you put after that, if everything's still working, it should show up there. And actually I should... I gotta remember to... It's gonna be in the test overlay, I think. It's the test overlay. I gotta remember to start up this program before I start everything else. Speaking of which, can I make the... Can I zoom in on this at all? No. I really need to like hide people from this user list. It'd be nice to get rid of the spam bots from this user list here in streamer.bot. But anyways, that program is called streamer.bot, and it's the thing that is acting as a proxy for our events. So all of our events are going from YouTube to streamer.bot locally, and then our WebGL scenes, both here and here, are connecting to that endpoint that's being created there. Here. And I gotta remember to start that before I start OBS. Otherwise, the server doesn't exist, so then the overlay fails to connect. But anyways, so we turned on orbiting controls in here, so I can move around and see how these HTML elements appear to be attaching. Like if we go behind it, there's no occlusion on it, it's just showing as a layer. And if we look, there is a little bit of thickness to these things. I can't move over, come on. Why aren't you letting me move? Is it middle? It's gotta be middle mouse button. Trying to get like just to the right of it. All right, let's reset. For some reason, it's not letting me translate. So we'll zoom in a little bit, and then we'll do this. I think this will get it to it. Oh, it's really hard to see, but I think in reality the text is positionally supposed to be placed behind these elements, which might be something we want to play with. So I think when we draw our rectangles, we get pieces, or from the origin we have like we got to keep track of the point of origin for everything, for like the global origin, but then for each one of these elements as well. I think the origin for it is in the like back left bottom corner. So like down here, if you can see with the cursor. Here, can I do I still have that on? There, yeah. Right there. This, hopefully you can see that in the overlay. I think you can see it, right? Yeah. So I think when it does thickness, I think it draws out from that point. And the text, I think, is on the back of it. When we turned on occlusion, we weren't actually able to see the text because it was being covered. It does appear that there's some sort of bug or something with it, but you know, that's a whole separate issue. Okay, so let's see what it looks like to get the physics system in here. And like you can see here, we're starting at 2. So like stuff still isn't quite lined up here as compared to there. So what we're seeing in the view there something is different. So we'll have to deal with that. Let's throw it in a physics system and see what happens. The first thing I'm going to check here is that when we put this in physics, all the boxes should be able to like move or fall down. We'll turn them on so they're fixed eventually. But we want to make sure that that text is attaching to that element still, even when we apply physics to it, or put it in the physics system. We have our models in a physics system already, so we can use that as an example here. On the right is the models component, and that's the thing that has all those GOTF models that dropped a little bit ago. And that's where we have the physics system implemented, and it's just another wrapping component. We're gonna just take off orbit controls for the moment, and all we are gonna end up doing is putting physics in there and importing it, and we'll see what happens. We will need our React 3 Rapier. Rapier is a physics engine written in Rust, and this is pulling in a compatibility package that takes that Rust program, creates a WASM file, and packages it up. If you're unfamiliar with WASM, it's kind of a nifty rabbit hole to go down, but it's I'll call it up and coming. It's been around for a little bit, but it's taking, these things take time to like develop, but also there's not a whole ton of money being thrown at it as much as other web systems. So it's taking a little bit longer than I would personally hope. I wish it would move faster because it seems like a really nifty and interesting tech. But the WASM ends up being a layer where you can compile many different languages to WASM, and WASM is a way to like interact with your DOM and JavaScript and such. Interact with your DOM similar to JavaScript, and you can wrap WASM in JavaScript as well. So there's sort of like interactive components there, or interaction components there. So physics imported. Let's go ahead and physics system set. Now we imported it. Let's see what that gives us. We do need to take each of these elements and wrap them in a rigid body. So there's a couple things we can do. We can make it a rigid body with different types, and this one in this specific case is a fixed physics element, which when we use that, it's in the physics system and elements will react to it if they like run into each other or whatnot, but it's not going to move. It's literally fixed. There's nothing no forces or anything that you could apply to it that would actually move it. We're going to take our key from the rounded box because we now have this as sort of the top level, or the root of this list, and that'll get rid of our React error with the keys. So now it's in a physics system. Theoretically, if we take off that type fixed, and we do a refresh, there we go. There's nothing there that it's actually going to hit. So what we can do to play around with it a little bit is we can say we want to make the type dynamic and say if index is greater than 4, fixed. Otherwise, I think we could just call it undefined. So now it's rendering index 0 is up at the top. So all the way up at the top there is index 0. So what we've done is like fix, like this one maybe. So all the other ones will fall on top, and we should get a little bit of physics. There you go. So you can see these down here are fixed. These are getting physics applied. We did turn off the orbit controls. I think the orbit controls are going to work on the physics system still. So let's turn those back on. And then we should be able to do this. Yeah, see, look at that. And it does seem like it attaches pretty well, which is pretty sweet. It's interesting how... So there's there's two ways. I believe there's two ways that you can do physics systems. The and it was what are they called? There's I guess it's indeterminate and determinate. A determinant. So I hope I don't get this flip-flopped here. But a determinant physics system is if you set up the same situation and do the same, like drop, like if you, for a simple example, if you take an egg, stand on top of a roof and drop it, and you drop it in the same way every time, you get all the variables are exactly the same every time. The physics reaction and how that egg hits the ground is going to be the same every time. That's a determinate physics system. And in real life, getting all of those variables always 100% the same is effective. I mean, at least for that specific case, impossible. So this is the reason here. I believe I've got it set to an indeterminate physics system, which doesn't necessarily mean that the physics is going to work the same way every time. And for our use case, we kind of want that because we don't want it to actually be the same every time. We're going to be dropping it the same way, doing the same like setup, pretty much the same all the time. But we kind of want it to be different, because it's not just a video. If it's the same every time, it's gonna look like a video. So am I getting it right? Physics, indeterminacy principle? No. Physics game engine. Indeterminate. I feel like I'm mixing them up, but also here, game engines and determinism. See, and this is kind of how going into explaining what we were talking about just now. Okay, wow. Here. So in this case, they're talking about the NVIDIA physics rendering engine, I guess. Like the compute drivers on the NVIDIA graphics cards have a physics system. And as long as you run the same simulation with the same actors, with the same frame stop, you'll always get the same results. So I did get the terminology right. So it is deterministic. But we don't really want deterministic in our case because we want a little bit of that variability so it doesn't look like it's just a video. So that's why sometimes it falls and sometimes it just doesn't. Of course, it's not always going to do that. But we do kind of want it to be just a little bit different every time. And that, in a way, makes it feel more realistic for our use case because in reality, there's lots of variables that go into physics. And it's in the real world is two things happening at a time span apart from each other. It's very unlikely that they're going to do the same thing every time because one of those variables probably changed. I mean, like, we're talking to the point where, everything is constantly moving. The Earth is rotating around the sun, blah, 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 blah. Like, the moon and the position of the moon affects how the oceans, like the height of the oceans, because that gravity pull is changing things. So, like, sometimes it might not be noticeable, but it is very incredibly hard to get all these variables exactly the same. So we want it to actually be, in our case, slightly indeterminate, or not, well, let's say, not determinate, because then it makes it feel more realistic, even though in reality it's actually less realistic. It's kind of the like in video games, if you make it too realistic, it ends up not being fun. You kind of have to keep a little bit of that arcadey in there. And depending on the game and blah, 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 blah. There's, of course, many variables that go into that too. But you can't make everything perfect to how you would see it in the real world, because some of that actually removes some of the thing that makes what you're working on interesting. So, long explanation. But we set this to be, or we want this to be indeterminate. And I don't think I actually did anything to make it indeterminate. And I'm pretty sure it's determinant by default. So yeah, and then there's the other thing. If you try to be too deterministic, it starts to have performance consequences. So at some point you start needing to do simulations rather than trying to put everything in a physics system. I want to say this is ideally by default deterministic. I'm not 100% certain offhand. That all comes into play though. That's the kind of the ways that you end up thinking about your physics system and why they might be reacting differently. So like that is kind of fun because we can then do, I think this will work. If we reset that, you'll actually see it there, which is sort of fun. So we can potentially do some fun stuff with that too. We might want actually that text occluded though, because if you're watching the text, if one of any block that falls over it, you can actually see that text coming down all the way through all of them. So we might want to turn on occlusion, which is an option in that try. This is sort of not blood vessels. This is definition number 2 is probably more closely to what we're looking at. We want to, when the text goes behind these, we don't want to show the text anywhere. But there was problems with the occlusion, so we're going to wait to turn that on right now. We're not going to focus on that. So we're getting the job. It seems to be sticking to it pretty well. Now we need to think about the positioning. We're going to switch this back to be fixed. We're going to have them all fixed at the moment. When we are doing our physics, let's look at one of our models. I think we do some stuff with the physics in here. This use effect is resetting an item once it drops. So what we're doing with the model is we're using a single model and we're generating instances using instanced rigid bodies. We are setting the initial positions and the number. I think where's the number come from? Count. Is that the only place we're using? Okay. So instanced mesh takes the count. So we're saying, hey, use this geometry and make, what did we do? 10 instances? 10 instances. And an instance having one, we only need to load the entity once, and then we can have 10 instances of it and it is more performant. And what we're doing is rather than like redrawing it every time or recreating that instance every time, I think with the instances you have to render them once. You can't really do what we're doing here, where we're just mapping over and using React 3 Fiber stuff. We want the instances to always just exist and reset their position. So that's what we're doing here. So in our physics system, we end up getting the API, which is a ref to our rigid body. So from that API, we can set or reset positions. So I think what we'll be able to do is spawn these in as fixed, or potentially do. I think we'll have to. I think it's just going to be easier to set them as fixed. But what we can do is, when we delete them, rather than just having them be removed, we can instead tweak their type. I'm hoping. In which case we can like take off the fixed value and just let it fall down. And then once it goes off screen, then we can remove its rendering. But we might actually be able to do the same thing here. I don't think, performance-wise, I don't think it's going to matter. We only have like something like, I don't know, 10, 15 of these boxes. I mean, if everybody does a single character, a single line, what? 20 of them maybe? I don't think it's going to be a big deal as far as performance goes. So it's probably easiest to just like unrender it. But if we want to like highlight something or move it, remove it, I guess, just taking off that fixed value would be kind of fun. And from that, this API, I think we can get the position too, because we have a mesh there. We can get the position and the size, and I'm hoping we can adjust the size there to where, based on the initial draw of this HTML element, if we can get the container size, convert that into WebGL units, then I hope potentially we can resize that box once it's all good to go. So that works. Physics seems to be working fine. Next item is to... Should we look at the ref? Should we look at that ref stuff we were just talking about? See what kind of information we can get out of it. I think we do need to fix positionally that. That's just not going to work. Obviously, we need the text to be in the corner and all be shown. Let's reset that so we got something better to look at. I reset the type to fixed here. So now it's just going to all stay, even though it is in the physics system. So the other fun thing is if we drop something and they're all in the same, WebGL scene and in the same physics system, stuff that drops will end up interacting with this, which I think would be kind of fun. So let's see if we can fix that text real quick. We spent a bunch of time doing that yesterday. But let's see what we can do with it. We're trying to understand what... I'm going to take off these orbit controls again. We were trying to understand what the positioning and how that... like, how is that positioning determined for that HTML text? We have this outer box, which is just the whole scene. As far as I can tell, it's this class is setting up a thing to make this match the scene. And then within there, we are adjusting the position. And I'm not sure what that's doing relative to this and why we need multiple divs. Because like this seems smaller. Well, no, I mean, it says it's width and height. It's doing some Matrix 3D stuff and translate. So we have a translate here. I'm not sure why or how that translate is calculated. We don't, Or we do also have a translate here, which is positioning. Okay. I see. So this is the outer container. This is another container that matches much of the same stuff. The big thing being different being the matrix 3D, which I'm guessing is what is trying to keep the thing attached. But it also has a translate. So it's shifting that whole box up and to the right. And that's why you see it going from here to here. So the translate is, we got the same box basically on top of each other, one containing the other, and that translates shifting it. And then within there, we are doing another translate of negative 50%, negative 50%, which is going to center this. But the problem then ends up being that it is smack dab in the center. So getting that positioned in the corner, I think it's going to be difficult. So we were going to dig into React 3 Dry. The API calculate position. This lets us override the default positioning function. And it is actually disabled when you have transform turned on. So this applies to matrix 3D transformations. Which I think we still kind of want. But if we have to calculate it all ourselves, we might just have to deal with it, you know. So let's take off this position and we'll take off the transform. Let's see what we end up getting. We also have some CSS in here. Let's go ahead and open that up just in case. Not doing too much, just setting the size of the font. I don't think we have any like default stuff in there, but it's resetting just in case. So without transform on, do we have that extra layer of boxes in there? So we get one box, no transform, and that. Now the question is, if it is a reference, let's turn this back into let's turn it back into this and let's see what ends up happening. If we have turned off the translate, are we able to see that text is not sticking with it anymore? Of course, this stuff is not going to tip. I'm not particularly keen on calculating that. Like, it feels like we do want translate or transform on. But it's not doing what we want. It's transform on. Here, we're just going to do this. Type equals fixed. It's definitely not doing what we want. Do we just dive right in and... This is why I turned off rotation. Like this... I mean, it's within there. Position absolute pointer events. And we do have a translate in there. We've got it here. Let's take this stuff off. Just make sure that's not doing anything else funky. So what we're running into is, of course, our text is small enough now that it doesn't, or that it's fitting. How about some more text here? How about some more text here? Yep. But this one is much longer than the others. Now, eventually we'll actually hook this up to the chat. I had been just piping in chat messages to test, but that was annoying and spammed the chat. So we switched to setting the default, just a default state. Now, if we type more things in there, it does actually end up updating. But does it? Do we still have it updating? Current state, yeah. I mean, it looks like it should still work. But then we can just hit refresh and see what it looks like, rather than having to constantly type test values in there. It's a cheap way to do a mock, as it were. So the problem we were running into here is that we've got to refresh. Apparently this is what happened. It appears to be centering it directly in the middle, so if that text is longer, we start overflowing this way, and it's not wrapping. Hello, backroom. Nice to see you. How are you doing? That's funny. When you typed, there you go. There's a text down there. So we're definitely getting text and whatnot showing in here. But we need to solve this container issue. And it doesn't seem like all this justification here. I'm having a great day today, backroom. How about you? It's vacation for me right now, actually. So that's part of why I've been able to stream outside of my normal stream schedule, but a few days in a row. Hoping to stream. What is today? Today, Wednesday? Hoping to stream tomorrow and Friday as well. Get a bunch of streams in here right after I did the official switch to YouTube. So, we are trying to get the text chat, which is showing up. Here's your text down here. And you can actually see the physics system going here. It's recalculating everything to get it like back into sort of a steady state. Am I going to watch the match today? I'm not sure which match you were referring to. Ah. I have a suspicion that you do not live in the US. I've kept a little bit of tabs. So I'm personally from the US, and historically the men's US team has not been great, and I've never been particularly keen on watching them, which means that I tend not to actually watch soccer or football, however you refer to it. I've only seen a little bit of the matches and whatnot, though. I think I saw some highlights from the Croatia versus. What was the last? I think it was their last match that they had a few days ago, a couple days ago. But I'll probably watch some of the at least the highlights on the later matches as it comes to a close. I enjoy watching the women's soccer, because the women's soccer US team is actually pretty solid. I do have a bit of interest in my lineage. My ancestors are have background in Germany and Croatia, so that's kind of why the teams that I've been paying attention to other than the US. So to answer your question, I have no idea who's going to win because I honestly have not watched enough to know. Morocco versus France. You're going to see it. Okay. Thanks for stopping by. So we're definitely getting the text down here on the bottom. And this container is I wonder if we can adjust this div, because I think we have control over this div here. Or maybe this one. So we might be able to I mean, if we adjust this one, we say something like the height is fit content. What if we say 30 pixels? Uh, 80. See, it's already adjusting that. That actually fits really well. But I don't know that we're going to be able to do it that way. We do the translate 50-50. We could potentially do a second translate. Or transform. Translate. -50%. -50%. And I think that's going to get us it definitely didn't do what I was expecting it to. So we're adjusting this. And within this container, how do we know, like, I guess we sort of have a fixed width. And we potentially have sort of anything left of the chat windows, that's potentially a fixed value as well. Although once we put it in the physics, things are going to move around. So I don't know that we can specifically keep fixed pixel values. And I still think this is relative to the center. So if we drop in a width here, and we say, well, let's just turn that off. We're gonna leave it there. I think we can figure out. Actually, I'm curious. Does that actually do anything? No. Auto. So none of these actually seem to do anything other than minimum content. So that's going to put it to basically the minimum width that the longest word is. And I don't think we can go with that. I think we're going to have to go with I think we can go with the percentage actually. Because I think this is going to end up being a percent of the window, basically. Which is effectively the same as pixels, but if I put it as a percentage, I can expand my canvas and these should follow suit. Although the boxes won't, so we might need to deal with that. But I have been toying with the idea of streaming in 4K or 1440p maybe. I don't know. It's probably going to be a while before I do it, but it would be nice to just not hard code myself into everything. So, I mean, if we do something like 45, we are still getting, if we do margin 0, there is definitely still margin there. Interesting that we're so like here 50 translation, is it going from I mean that like it looks like the container is just straight up like that margin on the right. I feel like that's misleading. So if we're setting a width and then the translate what does that end up being? Does this match? 55. Huh. So 0 translation still puts it right in the middle. If it is going directly from the middle of it, we want a translation that is going to be, gosh, it's gonna be is it gonna be the height of that object? God, it feels awful. So I don't think we could do 50, although numerically that seems to work out. Sorry, not numerically, like layout wise, that seems to actually be good. I'm not sure why that feels like that could just be pure coincidence that it's actually working out. Because we move that and then this suddenly moves. 70. See, like this feels not bad. $67. So like that feels like it works out. But if we put that in as the, so we've got a wrapper class. This styling here is going to be this one, that container. I don't think it's worth actually doing anything with that container. But in here, if we do a dot box, because our wrapper class is box, right? That's the whole thing. I don't think we actually want to do that either. So if we tweak that, we've got 65 and negative 35. Let's just copy that. Transform. And width is 43%. That's not going to give us what we want, because that is going to be affecting that like outermost container. I saved it, right? Yep. Interesting. It's got a box. It doesn't actually seem to be doing anything. Do I have that API wrong? Wrapper class. The class name of the wrapping element. Default undefined. So, I mean, I think a div is fine. Project content behind the canvas. No. Center full screen distance factor. Z index range. So we do this portal thing, and I think that's part of what's helping the attachment. And we do have some options with occlude. Why isn't that wrapper class working? It seemed like it was working yesterday. So I'd expect to see the CSS that we put in here. Oh, are we doing we need to do message classes box. Because we have CSS modules. And when the CSS modules get processed, there we go. That's what I expected to see. When the CSS modules get processed, it doesn't actually, the class doesn't actually box anymore. It matches that. So that's what I expected to see. So I don't think we could do this in the wrapper class. I think we end up having to do it. I don't think we have a choice. I think we have to do it here, which I think is going to complicate things because you know what? I think I might have locked my cat in the bathroom. Likes to sleep on the towels because there's warm in there. Would be right back. Do I have the screen's still up? All right, we're back. Yes. So the top one looks fine. The next ones don't. So depending on the amount of text there, does it? Oh my gosh. This has more but less. Great. We might have to do that calculation ourselves because this positioning is. So we are adjusting. We're adjusting the container, which also has a style. This div doesn't actually seem to do anything. I mean, it pretty much matches this, so fine. That is a translate 50%. But then it changes when we get less text. Let's try this one. Which one's this? Because the width is larger. Width is 43%. Now, is that percent like... I mean, I could throw this in the container. It seems we have to do this in the container if we're going to do it at all. So let's toss it in here. I think we're going to have to switch this to pixels maybe. So if we say 30, 80 pixels. Let's just take this style off here. What is that going to give us? So if we get a fixed width, that seems to be better than the percentage. So I think that percentage was doing, since we moved the percentage into the smaller or a more nested container, the percentage is not doing what we're expecting it to. So this translate is not right now. So if it is going right in the middle, if we say a translate of negative 40 pixels, and this is going to be the problem with the height. I think the height we also need to specify. We could give it a really big height and say, so if we say negative 500 pixels, which is huge, but if we say a height is going to be 1,000 pixels, what do we end up with there? Do we actually need to do... Oh, we need to bump up our width. What is... What? How does the height affect it that much? It's like a reflow thing almost. Oh. Interesting. So if we set the height, come on. I never quite know where to click. If we set the height to 1 pixel, 10 pixels. Anything negative actually seems to... No way. Okay, negative 1 pixels. So theoretically there's no height now. Invalid property value. I mean, it's kind of just resetting it, right? Is it gonna let us do that? Height. It's -1 pixels. It's not gonna be valid, but I wonder if that's like resetting the height, basically. Because we just want a container, and I don't want the transforms there to actually affect those at all. Okay, so now if we bump up this, yeah, as it gets wider, we are actually adjusting the but see, this kind of works actually. So if we do a transform of 0 pixels and of -20 and of 210, it does not feel great having to hard code all those. It definitely doesn't like that negative. It appears to just be straight up ignoring it. So if I do that, that's still controlling that. Oh, I did -20%. I was wondering why it wasn't letting me drag it. Something feels funky here. And I suspect that the moment I touch any of this, it's going to stop working. But if we can get that to line up, let's see what the physics then does with it. Reset our chat here. Seems to be fine. Now if we turn on physics, how is it going to track? It actually seems to be pretty good. Ugh. Calls for a good back crack. Ready for it? Oh, not as good as though it's open. I get so focused. I need that stretch. It seems to work. I feel like the moment I touch any of it, it's gonna break, but what we're trying to do is like trick it into like fitting into that container. And the height, we don't really care about. If we set the height and then we just care about the actual content itself. I might be able to get a reference to that DOM node and then figure out the, so you can see these top ones here, they're still falling and they will continue to fall. So we're not going to want that. Let's set them back to fixed for right now. The DOM node that we're playing around with is this one. And that has the class name. So we can Oh, okay, that's gonna bug me. So let's go ahead and give it a good reset. So you can see here, the text side is like basically 0. So we're almost gonna want like a containing container that actually holds the text, which just feels like a whole bunch of divs. So like this right here is our center of the element, basically at the bottom. So based on the text type, which is we've hard coded, we shift via this translate the container up to here by setting the height of 1. I believe what it's doing is it's immediately wrapping it, and we don't have like overflow hidden or overflow modified in any way, so it's just overflowing out of its actual container. So the container height is like straight up 0. But if we do div here, and this ends up being our containing div. If we then take a ref to this, are we using ref in here? We're not. I'm gonna have to look that up. We're using React or Preact in here. I think we're using React. Yep, we're using React. React ref. So there is a use ref, which we might be able to get information about this. So what we can do is, if our WebGL scene on every frame is recalculating and updating position, if we can update the height on every recalculation too, that would be fine. Normally this is like no bueno, because you render a thing and you don't want to continue re-rendering it to like get stuff to reflow and handle properly. But in our case, like that's sort of just the default expectation of the WebGL scene. So I think we can just straight up do a ref to it and get the height, and we'll just continue to get the height. Use ref, no space. I'm gonna just put it right up here. We're gonna say this is going to be our message box, and we are going to do a ref equals message box. We need to have the actual reference to it, not a string. So now that should give us the size of that. I don't know if this is going to work, but I think what we can do is log out the ref itself here. I don't know how often that updates or whatnot. Yeah, so like we're getting current is null. But then when it re-renders, or as it's like rendering, it continues to update. So there should be a target in here. Yeah, and like you can see we're getting children. So the way when you log something out, it's not taking a snapshot of it. It's like a live reference to it. So if this thing that you're logging out ends up getting mutated after the fact, you'll actually see it in here, which can be a little bit confusing. Sometimes there's cases where you want to do snapshots. Every time you do a log, you want to see the values at that position. Like when that code executes, you want to know what the value is. So it can trip you up in both ways. This that we're seeing here, current is null, when it first renders and first drops the log out, it is actually null. And then it continues to re-render. And we get the two like references to stuff here. So we get the React fiber. And I'm not sure if we need to do the fiber node or not. Ref current. I'm gonna assume we want the props. And I think we want to look for the target. Part, owner, style. So here's the text content, the name, scroll width, scroll height. $33. Maybe that might be the last one. So if we log out, let's do this. What we're gonna say is the text is something, and the height is going to be messagebox.current.scroll height. Let's see what that gives us. And then we can also drop out the text content. Messagebox.current.text contents. Now, I don't suspect that the helpers in VS Code are going to give us great information there. Yeah, so we're getting issues with null. So what we'll do is we'll say message box.current. If it's true, then do that. Otherwise, null should be fine, I believe. And now that's only going to log out. We get one render. When it renders, it's null, but the value afterwards, once it's done rendering and all the layout processes happened, should be updated. So I think if we continue to grab this, then we'll have something. So let's pull in, we were talking before about this, where we have an API. We set the API as a ref. I'm actually just gonna leave this empty as well. Well, no, we're gonna call it null because we want that initial render for it to be null. That's a little bit easier to know that it's the initial render. And then we're going to have a use effect. So anytime we might need to do it on animation frame. So we'll copy this. We're potentially going to need to change the use effect. So what's triggering it? Use effect is a way to, in React, fire off side effects, which can be pretty powerful, but it tends to be, I don't know if abused is the right word, but it was sort of the first primitive for some of this functionality, and it tends to be, maybe overused is the best word, in that there's potentially better alternatives now, more appropriate alternatives, and there's some of the newer stuff coming down the line I believe is actually going to be the better way to do like fetches and that sort of thing. But use effect kind of used to be the only real way that you could get things done. So like it was used everywhere. Like but then it gets really hard to reason about everything because React used to be about it being the view layer, now when every time you render, you're firing off all these side effects, it starts to get hard to reason about. So there was that weird state where React lost some of its appeal almost, I would say. And it's taken a while for that to sort of shake out and get better. And I still don't think it's quite there yet. I suspect that they're going to be able to work through it and get there, but it's definitely been a process. So same situation, we've got a ref, so that we're calling the dot current there. We need to put it on the rigid body. And we end up actually having, let's pull up the docs for this. React 3 Rapier, because and we might actually be able to update this. This is gotta have some new stuff, I imagine. It's still pretty new. When we were setting that other situation up, we had one API because we had one instance to rigid body. I'm not sure how that's going to work with ref. Can we do a ref to the outer piece here? Collision solver groups, sensors. It seems like they've got a lot more in here. Attractors. See, like this is going to be kind of interesting. We can do gravitation and stuff like that. I think we'll be able to do some pretty interesting things. Manual physics engine stepping. Here's in our rigid body, we can set the type of auto-generated collider. So we're setting physics colliders. Simulation runs in world space and is transformed to the objects look space that things act on as you'd expect. The only case where I'm seeing this API usage is with the instanced rigid bodies. Let's search for a use ref. Instanced meshes. I'm gonna just ref the whole physics system here and let's see what we get. With use effect, the second arg, the second arg takes an array of values that if they change, it re-triggers. If you have an empty array, you need to put something in there though, otherwise you get this infinite loop. So anytime you're using use effect, drop an empty array in there to start out. Because with an empty array, I feel like I'm talking with my hands a lot here today. With an empty array, it's going to only trigger on the first render. So what we can do is, this is only happening on first render. We're going to leave that in there just so we have a reference. We can reference it if we need to. And then I'm going to go ahead and log out API. Let's see what that ref is. And function components cannot be given refs. Attempts to access this ref will fail. Did you mean to use forward ref? So it might be that we do want rigid body. So these are demos. Let's look at the demo. Examples. Transfers maybe? So this has a use effect. Supposedly. Oh, I guess it's just imported and not actually used. Okay. Interesting. Group. Interesting. So they're doing a ref on the group. That might be the way to go. If we group this, we might be able to then put a ref on that group, of which then maybe we can use the API to loop through the things within that group. There we go. So we got a group. And then the children are 3D objects, which is good. I think that's what we want. And here we have we put a ref in here, right? Yeah, ref to message box. Come to think of it, that might not actually work because we're gonna like be resetting that ref every time. Let's look at the children. We've got children, so we've got children for each object here, and within there, each of those has a mesh, and then a group. Do we end up getting actually any refs to the related HTML? So this here would be the first element. So that's we're looking at like the object 3D information for this first box. Can I should bump this up just a smidge. We can see its parent, we can see the position, rotation, scale. So like we would be able to change which one would we change if we want to make it taller? Mesh. So we'd actually be affecting the mesh. Because this outer object 3D is the physics layer, I believe, that rigid body. Mesh, rotation, position, parent, matrix, material, layers, geometry. So like if we would go in and adjust some of these parameters, I think that's how we can change the size of the mesh. That's just get in 3JS. So we might be able to use 3JS. 3JS for that. Can we do a turn off automatic glider generation? So we can like on collision events log things out. There's other events that we can look for on contact force, sensors. A collider can be set to be a sensor. So this is something that we also might want to do. If we put a plane down, we'll know when something falls and hits the plane, in which case we can like remove rendering of it, basically. So that would be if we like delete this message, the message could just fall down. Once it, so the event of hitting delete would change the physics type for it. It would fall down, pass through a sensor plane, in which case we'll get another event that says, hey, this thing has fallen below. then we could have React set state, basically remove it from the state and de-render it. To unrender it, remove rendering of the object. Words. So we want to we don't have any events that seem to make sense here. Like there is some API here. I don't know if it actually ends up showing up on these. It seems that, like, if we look at the children, we don't have anything else that we're looking at, right? Parent, user data, UUID, players, parents. So this is looping through each. If we just have changed the size of each box, let's try going with that so far. So we have an API, and if we loop through, I don't know if this is going to work because this might be only for the instanced meshes. But let's go ahead and do a log for each mesh set of the API, and let's see what we get. So if we can do then something, this might start getting into 3JS where we can do a can I read properties of for each. So we maybe need to do children dot children. So we can say if API.current, because on initial render, it's not actually going to be there. I'm assuming this is the issue that we're having here. Cannot read properties of null reading children. And API.current. There. So, we should be able to get like a request animation frame type thing. Physics, and that's just coming through 3JS, I think. I feel like there was some examples of it. So options.colliders. And this one is hooks. Yeah, and there's the rigid body events, and that's where we start doing all these collider things. We can get the rigid bodies and do some interesting things like where we remove them. Let's look at the demos. I think it's been a hot minute since I looked at the demos. Let's see what they're doing. Let's see if there's anything a little bit different. Ooh, this is like a reflective glass. That's kind of nifty. So I'm presuming this is some sort of like instanced mesh going on here. You can see it's falling in the box, and we get a bunch of the like glass looking type thing. Joins, creative transforms. I'm not sure what the transforms is supposed to be doing. Oh, so like those are grouped. Cluster. And see, this is some of the interesting stuff that we might be able to do, where we can lock translation. So like we can lock some of these. Locked rotations. This is a nifty one. Let's look at this one. And it is interesting because I'm wondering if they are examples. Was it locked? Instant locked transforms. It's interesting because I'm wondering if they're using. Oh, okay. It is an option on rigid body. I have no idea what restitution is. But you can actually set this stuff. So we might actually want to do this when we set this in the physics system. If we don't want it to like fold in, we could just have it go straight down so it could only like move around and stuff. And that might be a situation where we could have, rather than like having, because we can potentially have a gap there, but we could have them just fall down and stack on each other. Which might get kind of funky. But if we don't let it translate, like in and out of plane, to where it can tip forward, it's probably not going to fall down. we might be able to get it to where they like just stack and fall on top of each other, and we can like I don't know. That might be tricky. We'll think about it though. Enabled translations. Okay, so it's definitely not quite what I was hoping for. See dynamic type changes. Yeah, so here, like we can change the type dynamically. So we'll be able to like switch it from one to another. Okay, and see these got different damping speeds. So like this one is being, the physics effects are being dampened more than the other ones. So that's why, even though they're the same size and everything, this one doesn't go quite as far. Mesh collider test. API usage. Okay, that is one that we want to look at because we want to look at the API. Oop, wrong button. API usage. So it is looking at the torus. Where do they have, do they have a ref? Use ref, torus. We are running it once and it's applying an impulse based on if torus is current. I think this actually does re-render every time because there's no trigger to like re-render it, and the ref is on the rigid body. So if we've got a dynamic rigid body, how can we do that? We almost need like a function for each, like a use ref situation for each that's doing this use effect. Which is sort of a pain. But like, see, these ends up being the things that we can do. We can set the translation. So I'm presuming that we can set other things besides that. And it is doing it on the, so there's the API for the rigid body. But then there's also the API for the mesh itself. And the API for the mesh itself is going to be more in line of 3JS. So this API that we're doing here, that's not actually the API for That's not actually the physics API. So I'm actually going to rename it as group. This is more realistic. We'll say group ref actually, just to not mix up with semantic elements. So I'd expect this to fire off every time it re-renders. But we've got a canvas. So we might need to, in reality, do another component here. I am literally just going to copy this. No. It's going to be too much. Rigid body. We're going to pull all this out. And we're going to say our new component is going to be called chat box. We're going to have to pass some stuff in, but that's not a big deal. Okay, I'm using function components. Function chat box. Not that it really matters, but consistency. We want to return this thing. Chat box is there. We also need the channel alert. We need the box. Do we have any other references? Channel alert and message classes is global. So we can say props equals channel alert and box. So now, oh yeah. Undefined reading X. So we're mapping in the channel alert. Index. I think I actually need to do this as well. Index. So rather than what I'm trying to do with the props, I think you could set props. We could set each of these. Like we could say channel alert equals squiggly brackets channel alert. That starts to get pretty verbose though. So if I could just do this and have the, what is this called? Shorthand syntax. Is that what it is? JS shorthand. No, object property shorthand. That's what it is. That I think is going to save me a handful of keystrokes here. Ironically, it doesn't seem to be working. Each child in the list should have a unique key prop. We are using the key from the channel alert, so this must not actually be defined. Can I do this? Is this, maybe it's not actually props. Channel alert. Like this. I know there's some syntax for it. Because you can spread all of the props. Box X location not defined. Yep, okay. Yeah, we're gonna start getting a bunch of these. Do I move these? Do I move them? Does it make sense to move them? Probably, actually. Just remove that period. So we don't have box. We do need to pass both those in because those are going to change every time. Okay, you do not like Box has already been declared. Yeah, we don't need box. Oh, whoop, I deleted the wrong one. I need index, not box. Message box is not defined. Something like this, isn't it? You know, like that. Channel alert. Dot 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 expected. So I don't want to spread it. VS Code seems, I think that's right, but it doesn't actually seem like I'm getting the objects as I would expect in here. Message box is not defined. Oh. Yeah, okay. That makes sense. I mean, that is sort of the whole reason I moved it down. It seems I've also lost the state. Channel alert. So those still might not be moving down. Yeah, I see you. Hi. Message box is not defined. All right, well. Wait. It should be defined now. Ah. But I moved this here. So this thing is for the group. And that's looping through the group. But if we want to look at the physics system, that's going to be a different API. Let's move that down as well. Stop. Come on. Yes, you. Just look at my green screen. Just bugs me. Things moving in the background is just unsettling. Okay. Can I do this now? Was it actually other errors that I was getting? Hi kitty. Coming up to say hi. Come on. Kitty. There we go. Say hi. You're not gonna talk, are you? She's more talkative of our two kitties. Cats, I guess now. They're getting up there in age. Well, not that old, but they're definitely not kitties anymore. Alright. Let's not bother doing the spread thing anymore. I'm pretty sure you can do something like that, but I want to just make sure that it's not my bad syntax here that is actually causing the issues. See if we can get it to work, and if it works, then we can always try to switch it back. And hopefully we remember it for next time. So it's still saying that we don't have a unique key. Channel alerts.map. We are mapping over. We're doing a chat box component. So channel alert. use alert. Channel alerts will be empty. Is it an empty array to start out? Default test state. It's actually a filled in array. Group ref is not defined. All right. Let's. Okay. Where are you? Where are you? I see you. I see you. Stop looking at. You know, I used to think she was doing it for attention. That she was looking at my green screen. I think she likes how it feels. Okay. Are we not getting the index passed through? Index. Console.dir. Channel alert and index. Let's just make sure we are getting the index. Okay, really? Do I need to lock you up? Is that gonna drive me? It's gonna drive me bonkers. I'm fine giving you attention if you stop licking my green screen. I'd say that's a fair trade-off, right? So we're getting an index. Oh, event ID. Is one of our event IDs not the? Is one of our event IDs different or the same? 1, 2. No. Oh. I know. We need to move our key up here now. So we actually don't. Well, we do need the index. We do need the index pass through. But the key isn't going to be on rigid body anymore. That is our issue. Key is going to be on chatbox. That's what it's complaining about. There we go. Okay. So we got that abstracted out. Now we should be able to more easily do a use effect with a ref to our message box, which is a ref to this, and a ref to the, so we can also do an API, use ref, null, and now our rigid body can also have a ref. There we go. And then within here, I think this is going to trigger on every render. Fine. Stop. Oh, kitties. What do we got? We get a lot of values. So we're getting the current now. And here, that's what I expected for the API for Rapier. So we get the values where we can set physics things. And then message box current. This gets into the React. Well, this is all React stuff because this is our actual element. So we should have a scroll height. Yep. And now I think that's going to be continually updating. So if we would do, right now we only care about the message box. So if we just say console.log, message, let's say text content and scroll height. And then we can pull these out. Scroll height equals message box.current. Just realized their music stopped. Let's do something a little bit more upbeat. Let's put some house on. There. Okay. We don't need this at the moment. That's not even gonna work. But I believe, I don't know how often this is gonna fire. It looks like we get it once for each element, and we are getting the scroll height just changing. So that's good. So what we can potentially do then is we have the... Yes, what are you doing? Now, if we have a ref to the ABI, the message box, and we say the mesh equals use ref null, that kitty is just insistent on licking that green screen. We care about the rounded box. And now we should be able to say what does our mesh for this look like? And that mesh, I think, starts to get into 3JS. Or at least the 3JS API. So we have a current, the children, material geometry. So I'm not quite certain which one we should do, but if we say 3JS, and we're sort of like being underhanded and going in there and like removing the fact that, well, we're modifying, it's like modifying the DOM without React knowing is what this feels like. If we're going to use 3JS in a mesh reference to edit the actual size of the mesh, is that going to mess with React 3 Fiber? That's a question that we need to keep top of mind and potentially come back to. But if we say 3JS mesh, we want to say size maybe. I mean, I don't want to scale it. How to get the width height? I don't want to get it. I want to set it. Set size. Let's open up the mesh reference. There's a lot of inheritance in here too. So that. In reality, I think we care more about this. But I don't know if we have a way to rotation scale up. Methods. Copy, get object. Values we can look at. We can rotate it and translate it. Updates the local transform. Possible that might be what we want to do. How to get the width, height, how to dynamically change the width and height of a plane. We don't have a plane. You can dynamically change the resetting the scale. We can scale it separate. That feels awkward, but honestly, oh, there. I don't feel like this is the right way to do it, but I don't feel like any of this is the right way. um, it's all kind of yeah. So it's not going to actually be in pixels. So what we're going to instead say, we're just adjusting the height. We are going to put the units at something like, I don't even, what are we at? 2.4. So we're going to increase, no, we're going to decrease to 1.5 because we'll be able to see that. So I think when these unreachable. React 3 Fiber's got a bunch of refs and stuff in here too. Actually try to recut this. Yeah. So like we've got a ref, so maybe we actually have to do current. It might not like us doing this. Oh. Hi. Ugh, come on. Come on. You can do it. There you go. Hi. How are you? Do we even have a geometry on here? Current geometry. There is a height, and it is now 1.5. Doesn't seem like it changed though. I have no idea if me changing this is actually going to change anything, but no. See, we don't have a value here. And I think that's because this is different for each. So what we're doing is just setting this value. Let's just hide this and let's just see what is in the geometry, and maybe we can just from there figure out what we want to change. Yes, hi. I don't need you in my face, please. We have two groups. Interesting. Here's a box. It's a bounding box though. Is that different than parameters? Options. So I think, yeah, we've got an extrude. So I think what it's doing is it's drawing a box and then it's doing an extrusion. So if we've got the because there's nothing else in there. If we're looking at the geometry only, is there like a depth? We've got a bounding box. I guess maybe under parameters, depth. Here's depth. Yep. So depth, I think, is the actual extrusion itself. Bevels, that's what we've got, a rounded box. So the bevels are like rounding off the edges. So shape, I believe, is what we're actually looking at here. And oof. Curves? Ooh. I don't think we want to. I don't think we want to deal with that because that's gonna get real sticky. I'm going to go with this. So yeah, no, I don't need you in my face, please. If we know. It's going to be a scale adjustment. So we're going to have to keep that in mind. We can potentially render this as the size of 1 pixel. If we can figure out, like, there's got to be a points to pixel ratio or something in here. So we can scale this then, I think. We want to keep the width, and let's just say the height is going to be 0.5. So now it should get smaller. If I do the right thing. I don't know if I have to call the update. We're still getting unreachable. Mesh ref. Current dot scale. No errors. Now the question is, it scaled the text. Blast. And it only did it for the first handful. What? Okay, that's kind of wild. Why would it just do it for the first handful? So you can see it adjusting. But why is it not for all of them? It must be something with how it's rendering. So anytime we might be able to adjust the size anytime it moves. Which is gonna be a lot. I don't know of a better way to deal with that though. We do have that scroll height there though. So can we get like a is there a helper for it in this to get like a points to 3JS points to pixels or something like that? How to render calculate the ratio of 1 unit to how many pixels? Like, see, it is going to be like dependent. So let's see. If I can get the offset of this, I want to fill in this here. First shape, get bounding client rect. So the mesh position Y top divided by the window inner height. I have no idea what they're trying to do there. That does not make sense to me. Mesh ref current. There's a bounding box on these refs. Geometry bounding box. We've got a min and a max. So these are the values of the size. And they're actually the size I'm expecting. I mean, there's floating point math in here, but 1.2, so it's because it's half. They've been like redrawn basically. That's gonna give us the size of the box. So if we have that, how do we map that to pixels? And they were saying window.inner height. I don't think I'm gonna be able to use that. And I don't think we can really use the scale either, because it's scaling everything else as well. So scan this in? No, because yeah. The size and local coordinate space has not changed. The size and world space has changed. So like, it almost feels like we do want to try to update the geometry somehow. Rather than trying to scale it. We should avoid modifying geometry after creation if possible. Yeah. So the problem is our text is also scaling with that. So if we scale the size, we need to like reset the scale on the text itself too. That is, I mean, it makes sense to scale it because we got a whole bunch of objects in there, and to scale it in one direction would be much easier than trying to like modify all those curves and everything and then the extrusion off of that, because we have basically got 4 lines and then we have the curves connecting each of those. So it's like we're gonna do something. Little scratch pad. So we've got, so rather than like a square would be 4 lines. It's not actually a square. Okay, it doesn't show up too bad. It's pretty reflection-y. And it's also like being green screened out, which is sort of hilarious. And we have basically like a beveled square. So it's not actually a true square. We've got 4 flats. Kind of like this. Oh, that's awesome. That actually makes it show up real well. If I can get it to focus correctly. We have 4 flats, and then we have the corners. I'm going to draw them like kind of exploded out. That are like rounded quarters that are doing the bevel. So if you like shrink those rounded pieces, it fits it into this like rounded square. And we don't have these edges that are terribly visible. So it might not be immediately clear that that corner right there is rounded, because that bevel or that round compared to the flat, there's a big enough of a size difference that this you can kind of tell it's round, I think, but it's like, it's subtle. That's the best way to put it. I think it is subtle. So to manually figure out all that, like refigure out all the math would be sort of a pain. So I think scale is the right answer, but then we're gonna have to adjust the scale on the text as well, which sucks. Which we might be able to do. I'll just like rescale it back, but we need to figure out that conversion. Stop. I'm about to lock her up because she is being very frustrating. We've passed the annoyed to frustrated. I should just like leave it out so she gets used to it. So I think we do want to scale. I think the scale is going to work, but we need to figure out what the conversion between pixels and scale. Yeah. Like I can still see it moving from. She'll move it and it'll just sit there and wiggle. 3GS. How do we even know how to like put pixels to units? I don't even know like what the units are. Hi. Yeah, I mean like this is in the sort of the same vein. Like you want to be able to measure. If I had a camera, so like camera movement is gonna mess with stuff too. Camera was set for it. Canvas, so I have to got my magic number. Okay. So like this. How do you calculate that? In the meantime, camera size and render size. So like if my field of view is 90, does that mean I've got like a conversion of 90? So if I've got 1 unit here, is that 90 pixels? That could be. That could be. So if I have 1 unit, so this would be this times. So if this gives me like an initial box size, I'm okay with that. And then we say, well, scroll height is going to be we'll just call it height. And if we say scroll height divided by divided by 90, because that's my FOV, does that give me the units? Like, do those units make sense? That's what we'll be looking for. We get a lot of 0.3, 0.5, 0.3. So that top one is a 0.5. No, I don't think it makes sense. Because the box should be, we want that box to be something like, it's 2.4, but I want it to be what, like 1.6 or something maybe? Let's try that. If we bump this down to 1.6, 2.4 to 1.6, what does that give us? Oh, it's still doing the scale. Let's take that scale off. Look at this. Get your paws off my keyboard. It's moving the boxes because the boxes are now adjusted in height. Oh. Because our location is based off the box height. Well, and what's annoying too is now the location of our because the height is from the bottom. Okay. The height is from the bottom, so when we reduce the height, this is like a fixed value, and this is what's changing. Stop. Okay. Okay. She is gonna go in the other room. I'll be right back. Okay. So that's frustrating because everything has sort of been hard coded for the height of of those boxes. So, which we were talking about, we thought it might actually be an issue. So I mean, even if we bump this up, I'm gonna look at this one up here. Did it refresh? I think it did. So let's save this 7.25 because I'm gonna play around with this number for a minute. $10. Is it moving it up? Doesn't seem like it's doing much. 35. Did I break that? I toggled it on and off too much. Come on, you can do it. Oh, well, no, I didn't do it too much. That is probably too big. I might just go back to that. So this is going to be the frustrating bit, is that we need a box with the size, then we need to adjust that size, and that's going to adjust the scale. So we need to, I guess what we can do is we can say, if we say 1, that's going to give us an initial size. You can see the text there. That text is going to be, let's reset that so we should be able to see something. There we go. Weird. It's there. Layout. As far as layout goes, it's sort of like oddly positioned, but that's fine. It seems that a 1 can support about 3 lines. And 3 lines is 50. Goes 17. Just pop open a calculator. I don't know how to do math in my head. So 17 times 2 is 34. So it's probably something like 16.5 times 2. And that harkens back to our text height, I believe, is 16. So 16 pixels. It's going to be all dependent on zoom of the monitor and browser and all that stuff. But like this is very going to be like our overlay here has very defined conditions. So I think we can rely on it a little bit. So 16 times 16.5 times 3. Whoa, times 3. Too many fingers. That gives us the 49.5. So one, what we'll say a unit const, we'll say unit is something like 18. Because, well, a little bit less actually. We'll say 15. 15 pixels, I'm gonna guess, is 1 unit. So if we take the scroll height and we say divided by unit, what does that give us as far as the height goes? 2.2, 2.2. This is going to be 3.3, 3.3. 2.4. So this here, well, no, I did my units off. So that actually seems like it holds more like, there's 3 lines right there right now. If we say that can hold 5 lines, so 1 line is 16.5 pixels times, it's about 5 lines. If we do that, what does that give us as far as units? There's got to be a better way to do this, but like, height. See, that just seems way off. We're getting our math backwards somewhere. So nope, it's definitely not it either. Okay, so this would give me it in pixels, right? Oh, and you know what? So I was doing this based off of 1. Okay, that's where I was getting it. So we can fit in 1, we can fit maybe like 0.9. So we'll say no. We can fit like something like 2.8. This is just a little bit skinny. So we can fit 3 lines, but really we got a little bit of overlap and such going there. So, you know, 1 unit, so a box, presuming a box is 1 unit tall, it can fit maybe 2.8 lines, or well, let's say it's 2.6 lines. So 1 unit in WebGL can fit 2.6 lines of text. This is so awful. Which means that I got this like text type number that we were trying to figure out before. So 3 lines. Okay, so 1 line is definitely 16.5 pixels. So this will give us basically the number of pixels to unit. So we're gonna call it pixels per unit. And now if we say our height, so our scroll height is going to be in pixels. So if we do scroll height divided by this, what does this end up giving us? It's going to give us a weird wonky number. Height. Yeah, so our height here is 1. Oh, no. Wait. What? When we had it as 1, I feel like it changes. So this is 2.4. When that object is 2.4, it's scaling it based on the size of the thing too, isn't it? Oh boy. Are we ready to do our own transform function? Let's look at their implementation. So I think what's happening is, like, if we look at this text, oh, it gets a little bit blurry when I just tweak it a little bit there. So this is 2.4. If we do here, I'm gonna do some rough screen measurements here. It's a little bit bigger than a thumb. This is gonna be real rough. If we switch this to 1, we toggle this. Maybe it's about the same size text. Maybe it's not actually scaling the text, and it's just some weird appearance thing that I'm seeing here. No, maybe it's not scaled. So what are we failing to do with this math here? We've got a scroll height of 50. 50 needs to fit. Let's do this. Let's do this backwards. We want our height to be something like, for 3 lines of text, we need it to be something like 2.5 or something. 2.8 maybe. So 2.8. And we have 50 pixels. And we're doing some sort of math to get to 2.8. So like that's going to be our conversion factor. If we have pixels, we're going to what's the pixels per unit? Times? So if I say, just got a calculator up, yep. So if I do 2.8 divided by 50.5. We can also do the opposite here and say 50 divided by 2.8. So if our conversion factor is something like that, let's just call it an 18. So if we say it's 18 pixels to 1 unit, that would mean that 2.8 times 18 should give us about 50. Okay. If we have a scroll height of this, divided by the pixels per unit should give us a height in units. Okay, I don't know what I was thinking of before with my math, but so that gives us a 2.7, which we had 2.4 before. And that was way too big. So if we go back to 2.4, that's way too big. We need 3 lines. 3 lines to fit to, I don't know, like 1.8 units maybe? Which comes out to be 1.8 divided by 3. So like 0.6 units per line. And if each line is 16.5, I don't know if that's actually right, but 16.5 pixels per line. We should be able to say that would be 16.5 divided by 0.6, so 28. 28 pixels per unit. And that gives us 1.785. That actually feels pretty decent. So now if we use that as a conversion and we say pixels per unit, gives us a height. Let's pull this out and we'll say const height of mesh is going to be this. And const HTML unscale ratio is basically going to be 1 divided by height mesh, so doing the opposite. But I guess I don't even need to do that. We've got the height mesh. It's unitless. Let's do, if we set the scale of height mesh, and then we say message box dot current React ref scale DOM. I think manipulating the DOM with refs. I don't think it's specifically a React thing. So there's a scale. Let's look at what this does. This is going to scale the box, which is then going to scale the text. So if we do that, the text is going to shrink or get bigger. I think we actually need to set this to be 1. So this text is getting bigger. We need to scale it down. I guess that makes sense because we're scaling it up. If we're using 1 as a base unit, so that would get, text would get bigger, and then we need to scale it back down. So if we look at that text specifically, can we scale it back down? So font size. What are they doing? Are they using any perspective, top, width? It still says it is the height changes. Does it make sense that the height changing is what? If I set the height, is that actually going to change it? I don't know. So if we say message box dot height, nope, dot current dot height equals that same, except we want to say we want to convert back. So height mesh is going to be like 50. So this is going to be like a 2 or something like that, 2 point something. Do we do divided by height mesh? Oof. Oh. And it's interesting, it seems to only be doing the first couple. So like we're gonna have to like recalculate this on every frame or something. So this use effect, is there a React 3 fiber request animation frame? Frame loop demand. A running frame loop is often even performance, because it doesn't need to warm up. If you use frame, okay, so use frame is actually what we want to do. Use 3. Let's do React 3 fiber use frame. So use frame is a hook that selector use frame, execute code on every rendered frame. So this is going to feel like we are doing a use effect, but instead of having this dependent thing here where we need to decide when to re-trigger it, we remove that, and it will, anytime this updates, it will rerun that. So we're gonna like be constantly recalculating the height, which I think theoretically could feel, yeah, see, now we're getting a whole bunch of these. So let's just take that out for a second, because that's gonna chug for a little bit there. It should be performant as long as we're not writing out console logs every time. So, oh, look at that. Okay. Nope. Because it's not actually it's not adjusting the scale. Let's take this out. And let's take this out. And let's see what it looks like if we do turn this on. And I don't think we're gonna have any logs, so I think it isn't gonna just chug. See, It's not chugging as much. But this is definitely not the right size. And like this one is small. So the ones that go onto 2 lines seem fine-ish. The ones that are on 1 line is still compressed. The ones that are 3 are still too big. So we need to, this doesn't seem to be working. Let's do a React ref scale text size. Scale text and change relative to container. Use callback. So this is actually changing the font size. I don't know that I feel the need to change the text size. Can we see what is actually changing? I think that's probably the biggest piece of this is it's not clear to me what value is changing that it's scaling it up. So if we can affect that, I think that's going to be the best way to do it. So there's a matrix 3D and a translate. It doesn't seem to be anything there. This still seems to be the appropriate size. This is definitely bigger. So is it this container that is now been recomputed? Tweaking that doesn't seem to be doing anything. That's curious that that actually changes it. This definitely does make it bigger. So the font changing definitely affects that. So what would be doing the scale? It's got to be a matrix 3D. Let's look at JavaScript matrix 3D. I mean, it's CSS, but okay. So the coordinates. That's wild. Rotate, translate. Like I don't really need to use the full bloody thing. Yeah, see, it's doing this transform. Which is sort of what it's doing here. Matrix 3D. So there's 4 dimensions. It's like a 4x4 just as a list. So A1s, A2s, or 1s, 2s, 3s, and 4s. I don't feel like that's actually doing anything. So 3D transformation is a 4x4 homogeneous matrix. Cartesian, homogeneous, generic, affine? They're not linear. Ugh. JavaScript, is there an easier API that we can use? JavaScript, font, text height? I don't want to measure it, I just want to affect it. So an increased line height. He's just adjusting the actual, like it's not adjusting the text at all. So that's not going to work. If we adjust the font size, that's going to is that in? Oh yeah, that's in Mac app. So I don't want to change the font size. I don't want to. I just want to scale it in one direction. Make text fit its parents. React. Scale text height. I mean, we are kind of scaling it. Yeah, and see, like this is the kind of stuff where it's like doing multiple recalculations, I think. I mean, we could check quick and see what they're doing. DOM utils. So they must be get computed style, get computed, get overflow. So there's scroll height and there's client height. And this might be the other thing too. There's scroll height and client height. I don't know what the difference is as far as current style. Get computed. So they're resizing. Handle resize. It's calling this dot resize. Get fill size set. So size. And size is being applied via this. So size is here. So it is adjusting the font size. So it's scaling the whole thing. It's not scaling it in one direction, which is what we have happening. React skew text size, because we have a skew, so we basically want to unskew it. So it's not a matter of us changing the size of the text. It's skinnier, so we need to like squish it, which is a change in one direction. And if we change the text size or the font size, we're scaling it in both directions. Based on the height of the lowercase, introducing this might. What does this look like? I guess I do want to look at that. I don't know that this is exactly what. So it's actually like moving it, motion path, and there's a font size in here. Transform. So this is text drawing and moving it around. DOM skew text. Text transform. Border, 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 width, height. So they're just talking about M's. Yeah, that's all gonna scale both directions as well. There's the text transform. What's that do? MDN text transform. I don't want to use W3 schools. Text transform. What do we got? Full width. Lowercase initial revert. Full size, full width. Yeah, that's not gonna work either. Decoration, emphasis, indent, justify, text rendering. What's that? No. I'm not really seeing anything that could potentially do. Build change with widows. Interesting name. Aspect ratio? Oh, no. Oh, yeah, obviously. Oh, I see, obviously, like, that's just adjusting. It's like setting a specific aspect ratio for that thing. Which I don't. Yeah, that's more just for like computing a box or like setting a box so things flow nicely within it. I don't think that's actually going to affect our text itself. Flex float font. Optical sizing. Interesting. Font stretch. Normal, condensed, or expanded. I mean, like, that's sort of what it's just in the wrong direction. Skewing into the other direction. I mean, I guess if we do that, then we could scale it down too. If we adjust the width to be the appropriate to fix it, and then we scale it back down. We might have to do that. Oh my goodness. Height, image, isolation, justify, line, margin, mask. I'm not seeing anything that's really going to help us out here. This is just a bloody pain. So we can do scale. Does that work? I didn't realize there was a scale. Can we do that? Message box dot current dot let's say DOM adjust CSS. Or I don't want you to dot style. Can I just do the dot style? And if we say I don't know if that's expecting a string or not. So we can set the transform. Okay. We need to adjust it based on the height. So this ends up being a string, I think. So if we say style.transform. Is that what it is? Go away. Transform. Transform has this, and we can do translate and we can do scale. So if we do scale and we say scale, scale, and height mesh is going to be a bigger number, so we need to say const. We're going to call it descale, 1 divided by height mesh. I took this way originally because I didn't think I was going to need it, but we want to unscale the height, and then this scale is going to stay the same. Oh, it would be great if this works. What? I mean, the positioning is going to get real weird. But this might work. Because now we need a gap and we need to know like the previous position of the other one. Let's do a let's turn on physics. See what that looks like. I think we're getting. I mean, we've been going for a few hours now. I think this is gonna kind of be to the point where we're gonna call it a day. Yeah, it feels like this is just ugh, but like it works. So I'll take it at this point, I guess. And we've got it in the use frame, so it's going to continue to recalculate. So what does this look like? I mean, these seem like appropriate sizes. Duplicate key type. Oh, yes. So if we look at the top box, come on. You're not going to tip, are you? It seems appropriately sized. So now if we can work on that positioning of the text within the box, and the positioning of the boxes themselves, we might be fine. We can. Yeah, let's see if we can get this text worked out. I'm actually kind of curious what it's gonna look like here. Oh, come on. Refresh, you can do it. Like my whole thing refreshed. That's fun. That would be fun for like a clear command, like just as a command or whatever. Somebody can do clear and just goes, just falls down. I think we can have fun with that. Okay, so I don't really care about the max characters. A bunch of this ends up going away. The gap I think makes sense. Although it's based on the box size now, so this is probably going to be more like a 2. Well, we're rescaling it. So I can't calculate it based off the gap anymore. I almost need like the previous. I need the position of the other box for the layout. Oh gosh. Okay. What if we just go big, and we're gonna say 5. We're gonna give it a gap of 5. And what if we lock the transforms and where is that gonna be? In this lock? Not that lock. I think it was in the demos. Hooks. Oh, nope. Wait. What do we do? Where are we? We want to go into demo. Demo source. Examples. Locked transforms. So like the reason we're looking at these demos is it has a bunch of these things like locked translations. So with this, it's not going to move, but it'll do physics things. Well, we don't want to. We want to turn off rotations. Because we don't want it to rotate at all. It didn't seem like it actually worked though, because once it hits, it just like sloughs off. Enabled rotations. Oh, wait. Put it on the wrong one. Put it on the wrong box. That needs to go on the rigid body. So this is gonna like prevent them. Can we see that in here? Okay, well, I mean, that's kind of fun. We need to update the first box location. We're going to take that off. And we're going to say something like 20. And we want to fix... This is what we're going to roll with. But we're going to say something like 20. And we're going to like fix the bottom one. That didn't work. So where's the bottom one? I have 11, right? Whoop. How many do I have? I suppose I could just scroll down and look, but I just want to fix the bottom one because then that one's going to serve as the layer that everything lands. We are still getting some like matrix or some here, let's bump that gap down just a smidge. Actually, I don't think the gap is doing anything anymore, but oh, I guess it is. Do so I mean, if we could do something like that, we're like it's like warping through, so like we would have to potentially do something to prevent that, but like that looks kind of hilarious, where if we just fix the bottom one and have the bottom one down here as the like anchor and everything just lands on top of it. Every time I get a new message, it's just gonna look like they all just shift down, which is kind of fun. Because we can potentially do something like in the attractors. Let's look at this. Let's look at this. Whoa, why are we so zoomed in? There's repellers and attractors. obviously we don't want that. That would be a little bit wild. Locked rotations, locked translations. We can put some damping on there. That might help out. And like tweak the kinematics slightly. All shapes. So what am I thinking? That's gonna chug things. So this is the instance message meshes, so we can have a lot of them. Like I think we could potentially do something like this, where they repel each other slightly. So sort of like magnets, where you get a little bit of a rump, because they would like hit in contact and then like go back out. It didn't refresh. Because if I turn it off and on again, I need to go a little bit slower. There we go. So we could potentially do something like that, and then we deal with the positions that way. We're gonna have to tweak the text. This feels awful to do, but I don't think we got any other choice, because we need to know the size of the text to be able to figure out the size of the box to match. So then what we are left dealing with, like this seems like it feels like it's working. Those are lots of words. I think this is good. It's sort of cursed, but I think this is going to work. So now we just need to figure out the text translation layer. So like, how do we get that to like sit in the right spot on the actual thing itself? I think once we figure that out, I think we're gonna be golden. Howdy. Nice to see you, Jono. Scott. How are you doing? We're just finishing up here. We've got we're working on re-implementing our chat in the move from Twitch to YouTube. I lost my like chat reel, and we're having fun with it and actually putting it into a WebGL scene and applying physics to it. So let's see if we can get it to do the thing. That's not gonna clearly work for chat reel, but there's still some tweaking to do. It's getting close though. We got through a bunch of complicated issues as far as that text, which I can almost point to is HTML, and it is being positioned over the top of this pink thing, which is WebGL. And we have a bunch of like reflow issues where the text height needs to be calculated and figured out in the DOM, and then we need to take that value and then roll it into the size of the box itself. You like the YouTube live experience better as opposed to Twitch? Big Tory fan. Nice. Good to hear. Yeah, that's good to hear. I'm definitely always interested in what people are doing with it. We've done a fair amount of it on stream. Eventually, I would like to do more with it, especially insofar as developing for it. So not just using it, but being part of the core team. I would love to enable more people to commit to the repo, because that helps everybody. But also seems to be there's that obstacle of getting people over the first hump of like getting involved, and removing that would be amazing, I think. But yeah, we got the text there. Styling and all that stuff clearly could use some work. And I mean, the size of the box is pretty decent. So like as we keep typing, we might get a better idea of it. We actually need to reverse it. I just realized we need to. These are gonna come in the other order. We want them to be top down. So where's our map? Reverse. And here we're gonna say if index, that actually makes that a lot easier. If we just fix the bottom one, let's reset this. I guess if they're reversed, it doesn't make it easier, does it? It's reversed. My index of 1 is actually, yeah, it's the top one still. Womp womp. That's fine. We do a, where's our map? We're doing a map with a chat box. We put it afterwards? Can we map first? Map, and then the index will be flip-flopped. Let's give that a shot. We're curious to know if it's feasible to rapidly prototype a UI in a web view using React and then gradually implement it natively using Rust. Interesting. I think my first question would be, what is your definition of natively using Rust? I think that's the first bit that would need a little bit of clarification. Will there be a cross-platform native UI, a bit like React Native, but for desktop? So what you're talking about is native elements. And that's very platform dependent. So the value of something like Tori and using a web view is that within the web view we get all the value and the tooling that has been created, mostly via CSS, I guess, to do all the styling and the look and feel of the app. The Windows stuff is a little bit more involved, but most as far as the UI of the app itself, you control that all via the web view. The issue then is that if you want to say call some of those components native, native is relative because that app theoretically, we just added mobile support in an alpha, I think. Was a beta, I don't remember. It's been on main for a little bit, the main branch. We've got 3 desktops, well, 2 plus Linux, whatever flavor of Linux, Android and Mac, or iOS. Native is going to be different for each one of those. And I think one of the, I don't know if I would call it an issue per se, but one of the things that people ran into with React Native is once they ran into performance issues, they were able to like take a component and say, I want this thing to be native, but now they need to program it X number of times. Ish, because that component needs to be created for each target that you're delivering to. With a web view, you don't have that issue, and I think so. That there's a little bit of a question as far as why would you want, well, like what's the use case or what's the drive behind wanting to switch to slowly, gradually implement natively using Rust? The presumption would be you want to do that due to performance. And I think considering that, I don't think the component itself necessarily has to be developed in natively as far as the implementation goes. I mean, whole ton of caveats here. Like, performance is going to be very different per each use case, and there are going to be situations where Tori just does not fit. Like, that's just how it is. Like, if you're doing something that is very performance sensitive and it is very specific to that target that you're delivering to, Tori might not be a good fit. Maybe eventually, maybe we figure something out. But until then, I think the thing that I would look to do is, rather than worrying about the UI itself, it's the data or the number crunching or anything that's performance sensitive. You could shift that into the Rust backend and do the calculations there, or what have you, and have the web view be more of a view layer. The only issue there is that the communication between the layers right now it's fast. But if you've got something that's super performance sensitive, like somebody was trying to implement I guess basically a terminal. You type in the web view, it goes to Rust, does the things, and responds back. That typing, you're gonna notice if there's a little bit of a delay. So even if there's very little delay, you might still feel it. So there's things that we've been doing, or ways we've been testing to improve that communication layer. The way it is right now is partly due to security reasons, but there's potentially other options or other methods that we can explore to have that communication layer be quicker. And I suspect, as that's smoothed out, that most of the concern as far as wanting to switch out of a web view to only Rust, I think if you could do most of the heavy lifting in Rust, that's going to cover a lot of use cases. And then the use cases where it doesn't, it might just make sense to do it in Kotlin or Java or Swift, or what are the desktops these days? Can't think of what it's called. Qt is I think a popular one. .NET got a bunch of stuff too. But I don't know that there's. I think it's not a true line in the sand. It's not necessarily, at least not right now. It's not if you're doing X, use this. I don't think things have been explored enough, and I don't think Tori is mature enough to really definitively make those calls. So it sort of sucks to say try it and see, and when you get bit, report back, and we can see where we can move the goalposts. But does that kind of answer your question? That was a really deep answer. But this feels like a very nuanced topic, so it seems like a really deep answer is a necessity almost. There's just so many caveats here, and it's so dependent on many things, that it's just hard to give general advice or thoughts on that. Anybody else watching too, feel free to leave thoughts in the comments. This is the kind of thing that it's great feedback and great input. And like I was saying before, I want to enable people to help work on this. I've been talking to Jonas from the core team as well, and we're talking about doing some collabs. And I think Jonas has been working on another communication method for a communication layer. So that might be something fun to explore in the future stream. But it would be fun to enable more people to help out. It's not it's a big project, but not in the way that I think prevents people from helping out or working on it. But there's lots of things or places or niches where we can push things forward. Your use case is native look and feel, write once, target 3 platforms, and performance. So then the native look and feel is going to be interesting because everybody has a different, every operating system or target has a different definition for look and feel. The definition might be so it's one example is if you use Material UI, which is very much an Android thing on iOS, it's going to feel out of place, and it almost begs the question of, is it even worth trying to like do an abstraction over that rather than just like programming the UI twice? And like some of these things were what React, I mean, you called out React Native. That's sort of what React Native was trying to address. But you have these like built-in expectations that you're working around. So you might be able to write some of the code once, like the business logic once. That view layer stuff, it's gonna get real hard though. And like I said, performance it's really highly dependent on the type of application and what you're expecting out of it. And you can move a lot of that heavy lifting to Rust, a lot of that business logic to Rust. And as long as it's not view layer specific, I think you can potentially get solid performance, have the business logic abstracted out to where the look and feel ends up being something that can be implemented multiple times without a terrible amount of effort. And then that write once ends up being like write 60% of it at once, or write 80% of it once, or however it ends up being worked out. And then that last like 20, 30, 40% is going to be native look and feel, and potentially a very specific operating system implementation things. So if your view layer is going to be the thing that qualifies the performance, if your view layer is going to be the thing that dictates the performance sensitivity of your app, I think that's going to be where you run into issues. In Rust does have targets, and you can write chunks of code specifically for platforms, and when you compile it, it will drop out all the code that you're not using for that specific platform. So you can do sort of the thing that React Native does, where, hey, we're hitting performance issues, let's write this piece in a specific platform. You can kind of do that except in Rust, and it's like built into Rust, like that's part of the Rust language. So if you have something where you have like some calculations or like desktop specific, or like if you're doing audio controls, those audio controls are going to be very different and dependent on the operating system that you're working with. So like the desktops will have sort of one set of APIs, but they're all going to be slightly different. And your mobile's going to be different APIs, but probably quite different. You could write that 5 times And then your front end is just saying, hey, I need to show a waveform. And that waveform is going to be the thing you might need to tweak the look and feel of that, the container, the boxes around that waveform, but the waveform can look the same on all 5 platforms. So it's super dependent. Like I said, it's really hard to say, do this. This is the way to go. You know, we're not going to have the Mandalorian. This is the way. Jokes don't get better. You know, that's how programming is. The best consultants say are all, well, I was about to say the best consultants always say it depends, but also that's not necessarily the best consultant either. So that also depends. Nuance everywhere. But hopefully that helps. You said good answer, so hopefully that kind of gives you a little bit of direction. And like you can take Rust and you can throw that into WASM, and that WASM can actually work in the web view as well. But that also has communication issues. So going WASM to DOM is not particularly speedy or performant right now either. Obviously relative. You know, it might work for some use cases, might not. Figma is done. Is Figma done in Rust? Is it Rust compiled to WASM? I don't remember. But the Figma, which they just got bought out, didn't they? Figma. That, as far as I'm aware, is still done in WASM. So like you can make things work, and then like this WASM, you can kind of write that once, and that could theoretically work on multiple platforms. So, you know, it depends. Hopefully that helps. Back to what we were working on. I think we were just about finishing up here. We got this. Did we end up getting that to work here? Did I break it? I broke it. Okay. JSX dot reverse is not a function. Okay, I broke it while I was talking. Oh, I put the reverse on the chat box. We need to do it here. Yes. So I want the index to be in the order that we're seeing them, but I want the reverse. That's not working. So the 0 should be the top. I wish I could see what value that was. Looks like 3 lines, so that's got to be the top. So it reversed properly, but that index, we are fixing the location of the first one. Where do we do it now? Fixed. So if index is 0, so it must tweak that index then. Oh well, I mean, it's not that big of a deal. We can do if index equals map here, we'll reverse. Take this reverse out. I think it's clearer here anyways. We're gonna reverse the whole thing, and we're gonna map over it, and we are pushing in the array or the index, so each item is going to be an index number, and then what do I call this? Alert array. And we can do alerts. Should we just say all alerts? don't know if I really need to pass the whole thing, but alert array. I'm actually gonna change that. I like the all alerts, feels better. And then I think what we can do instead is in here we can say if index equals all alerts dot length -1, I believe. Array things, array numbering. All alerts is not defined. Didn't map have a map is, oh no, callback function and index. I'm thinking it would reduce. We can do that. All alerts is not defined. So all alerts, channel alerts for passing and channel alerts. Oh, I know what we need to do. We need to also say all alerts is here because we are referencing it here. Dot length. There we go. So we'll have to work on the physics a little bit. We'll have to deal with the gap, and like things are still sort of like falling through each other here. So we might have to lock translation in one of the Do we have lock translations? Either boo locks all translations out. Lock rotations. Okay. Enable translations. So if we say true, 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 that would be enabling all of them. And we want to make sure that it doesn't move in and out of plane. So if we say false here, that should let it not like jump out, I believe. I'm kind of curious what it looks like here. Yeah, we're gonna have to like make these really heavy or something like that, because we don't want that to happen, that they like flip out, just absolutely go bonkers. And when you stack a whole bunch of them like that, we're gonna get that. I mean, I can turn this down just a smidge. That gap between them might help out a little bit. But it's also going to be really dependent on, yes, you know, they're really high up in the air. First box location. Let's bump this down. So like, that's not so bad. Did it work? Off. On. Ugh. So I mean, I think we can work with this. We'll want to put a little bit of a damp and make the physics engine think they are heavier, so they don't bounce around so much. Like, we don't need a bunch of bouncy balls. We want like big honks of steel that like drop and stop, don't move, because they're really heavy. So we can crank up the damping, I think, for that, and that will, I think, fix a bunch of this unintentionally. And then now what we're doing, we can fix the bottom one, and we can just fix it down here, and that's going to end up being the way that we determine like when stuff falls off. Yep. So and then we'll be able to like do an impulse or something like that to push them out and like yeet them out that way if we want to delete them. And that I think will work fine. Yeah. So then I think the only thing we need to deal with is this text. This text needs to fit in the side of the freaking box, and then we'll do some CSS and styling and whatnot to get the look and feel a little bit better. But I think we're getting there. This was not an easy thing to deal with. Here, we're gonna flip over. I think I'm about done talking about this. This was not easy to deal with. I mean, we expected it, and hopefully updates in the packages don't break stuff. It could happen, but this isn't terribly involved as far as like implementation stuff goes. It was more just like playing around and figuring out the best way to do it. And now that we're sort of familiar with potential options, I think that'll help if something changes. But you know, I think that's gonna work. So tomorrow, I should be able to stream tomorrow. This was actually a long stream, but I think we made a solid amount of progress. We'll see if we can get that text strangled into the right spots. The boxes are the right sizes now, so you know that's something at least. But we'll play around and see if we can get those boxes in the right spots. The text within the boxes and attached to the right spots. And I think we'll be good to go with this. Hopefully we can get it all squared away by the end of the week, and then follow on streams will be more back to the regular scheduled stuff. But we'll knock out as much as we can here and roll into the holidays. So thanks for stopping by, everybody. It was a fun stream. We had some good questions unrelated to the project, but happy to answer them as well. You know, I've got plenty of videos up, so you know the things that I've gotten into. And there's, I mean, that's a subset of the things that I've gotten to. But on stream, you know what I've gotten into. So I was happy to answer questions. I will see you again tomorrow, or Friday, and then roll into the holidays. Cool. Bye.